Hey guys, test 18 reviews, knock this thing out. All your formulas are on top, they'll be on top for you tomorrow, so make sure you know which one's which. The first two are arithmetic, the last three are geometric, and that's the only difference. So here we go. Number one, find a common ratio. Remember to find the ratio, you put the second term on top of the first term, reduce it the best you can. That's negative a half, that's all you do there. The eighth term of the geometric, the eighth, I should have put an 8 right there. The eighth term is the first term times the r, and r you can tell is 3 there, n minus 1 power, n is 8, so I'm going to put 7th power right there. Just going to punch that in my calculator. I'll punch it in and I get 65, 61. Now in this review, probably a good idea if you punch it in your calculator also, make sure you're getting the same thing. Number 3 says find the nth term. When it says find the nth term, they just want you to write the formula. Plug the numbers in the formula that you know. So I'm going to say the nth term is the first term, which is 12, times r. r again is second term over first. 6 over 12 is going to be 1/2 to the n minus 1 power. That's all they want you to do. The nth term means what is the formula for the nth term? Number 4, be careful, number 4, in your calculator. It's not hard to set up to write it out, but punching in your calculator, just be careful. It's the sum, it's the geometric sum that's on top of your paper. I'm going to do the first term times 1 minus r, which is 2 to the 7th power over 1 minus 2. That's the formula from the top up there. Also, if that 2 right here that I'm pointing at right there, if that were negative or a fraction, I would definitely have it in its own parentheses. If I were you, I would just punch the top in my calculator. You can tell the bottom's -1, so I'm going to take a second and punch that in. And I'm getting negative 889 over -1, which is positive 889. And there you go. Number 15, find the sum of the infinite geometric sequence. Okay, infinite, the sum of an infinite. You can see the formula that has the s with the infinity symbol. Now remember, you can only do this if r is between -1 and +1. R in this case is 3 over 6, which is 1/2, which is awesome. So I can find it. So I'm going to do sum is the first term, which is 6 over 1 minus 1/2. And I'll punch that in if I need to. Actually, the bottom's a half. 6 divided by half is actually 12. And you do keep change flip. There you go. Number 6, sigma. The good thing about sigma is we have everything. Anytime you have a number with an exponent, that means it's geometric. So I'm going to do the sum of the first 11 terms. Remember, 11 top minus the bottom plus 1 tells you how many terms there are. To find the first term, I'm going to plug the 1 in there. So it's going to be like 2/3 to the first power, which is 2/3, times 15, which is 10. So I hope you get that. That first term is 10. Be careful there. 1 minus r. R is whatever the exponent goes with, to the 11th power over 1 minus 2/3. Okay, so 1 minus 2/3 on my denominator is 1/3. I know that. I need to punch in that numerator real quick. All right, when I punch that numerator in, I'm getting like 9.8843. Big old decimal right here. 88438, and it just keeps on going. And dividing by 1/3, the same thing as multiplying by 3. So I'm on my calculator hitting answer times 3 and getting 29.653, and that keeps on going also. Try to hit math frac, but I don't think it's going to do that for me. No, it's not going to change it because it's probably an irrational type number. So there's the first 6. Number 7, back to permutations. Number 7 is a complete calculator problem. You need to hit 12, P9, permutation 9, and just on your calculator, get a big old number here. Getting 7, 9, 8, 3, 3, 6, 0, 0. So about 79 million there is all there is. Number 8, how many permutations are there of the letters in the word flowers? Does it say flower or flowers? It's gonna, flower, if all the letters used without repetition. Okay, so if you can use them all and not repeat them, you can just do, let's see, there's 6 letters. You can basically do 6p6, which is exactly the same thing as 6 factorial. And if you do 6 factorial, getting 720 there. So there's 7, that's crazy. 7 or 20 different ways you can rearrange the words in the word flower if you don't repeat letters. Number 9, how many 4-digit numbers can be formed using those digits? 2, 4, 6, 8, 9. There's 5 digits without repetition. Okay, so that, if you're not going to repeat them, that's just a 5p4. Okay, so I'm going to do 5, math, prob, 2, 4. I'm getting 120, 120 different ways if you do not repeat them. Now, if you do repeat them, basically, you're doing a 4-digit number. So you got, 1 digit, 2, you got 4 different digits. And you can use all 5 numbers for any digit because you can repeat them. Okay, so it's really 5 to the 4th power. And everybody knows 5 to the 4th power is 625. And there's 9. Number 10, How many permutations of the letters of the word cabinet is letters taken 4 at a time? Now the key here is the word cabinet, all the letters are different. No letters repeat, and there are 7 of them. So basically, you're doing different arrangements. Arrangement means permutation or order, different orders. So I'm gonna take 4 out of the 7. I don't know why I put C. Should be 7P4, sorry about that. 7 math. I'll do my calculator while I'm talking to you, sorry about that. That's 840. That's crazy. 840 different ways to pick 4 of those letters and arrange them. Number 11, the difference in 11 and 10 is 11 is the word Mississippi. So Mississippi has letters that repeat, and it's a special problem. When you have items that repeat, the way we work that out is we take the total number of letters in Mississippi, which looks like there are 11 of them. That goes in your numerator. Your denominator, you put all the letters that repeat. For example, there are 4 S's, so you go 4 factorial. There are 4 I's, so I'm doing 4 factorial. There are 2 P's, so I'm doing 2 factorial. Now, the hardest thing about this one's punching it incorrectly. Your whole denominator must be in a parentheses, so be careful there. I'm going to pause this a second and go punch that in, because it's going to take a second. Okay, after punching all that in, 34,650, boom. Another good word for that would be like Tennessee, just saying. Okay, number 12, combinations. Combinations when order does not matter. It doesn't matter about arrangements. Order does not matter. I'll change colors because we're starting combinations now. So again, just take your calculator, 8, go to Math Prob. You'll find the C button there, the combination button there. You get 28. All right, number 13, there are 24 students in a fraternity. How many sets of 4 officers can be selected? Here, order does matter. Like the first one you pick may be president, second one may be vice president, etc. So it's a C. We're going 24 C4. So we're going 24 math. Prob C4, getting 10,626. And number 14, on the test, let's do this like 12 out of 15 questions. I'm sorry, on 13, I said that backwards. I was thinking about that as I was talking through this one. The order does not matter here. It doesn't matter which order you choose the set of 4 in. It's the same set of 4 people. So order did not matter. Sorry about that. I described that wrong. 14, on a test, the student is just like 12 out of 15 questions. Okay, think about this. If you only have to answer 12 out of 15, doesn't matter which order you pick your 12 in. And the answer is, gosh, no. So it's a C. It's 15, C12. So I'm going 15, math, C12. I'm getting 455 right there. 15, how many 5-card poker hands are possible with 52-card deck? Again, you got to ask yourself, does it matter which order you get dealt the cards? Like if the order doesn't really matter, you're just going to get the same hand regardless of which order the cards come to you in. So the order does not matter, therefore it's a C. So we're going 52, C5. That's going to be a big number. I got a bet there. Yeah, it's pretty good size. So it's 2, 5, 9, 8, 9, 6, 0, which is over almost 2.6 million different hands in poker, which is crazy. Number 16. Just square that thing. Okay, so square, multiply, double, square. If you square 4x, you square both the 4 and the x. Multiply together, double. If you multiply those two, you get 20xy. If you double 20xy, you get 40xy. Then square the 5y. When you square the 5 and the y, and there you have it. Number 17. Factor that thing. That is slide, divide, slide. So I'm going to slide the 6 over, get x squared plus 11x minus 60. So I'm trying to figure out factors of 60. That would give me 11. Everybody knows that's 15 and 4. And don't forget the last thing. We slid. Now we got to divide. So divide by the same number, divide by 6. Let's reduce those before we slide them. 15/6 is really 5 halves. 4/6 is really 2/3. Now slide. Slide the 2 back in front. Slide the 3 back in front. That's a pretty good problem right there. Pretty good factoring problem on number 17. 2 more. 18. 18, lots of ways you can go here. 18, first of all, 32 divided by 4 is 8. I'm going to have an 8 in my numerator. By A's, the bigger A is on the bottom, is 3 bigger, so I'm going here. My B's, I'm going to flip them. The B6 comes at the top, the B4 goes in the bottom. Now I find the bigger B. The bigger B is in my numerator, and there you have it, right there. 19, haven't done this in a while, solve the triangle. It's law of sines. I thing. Yeah, because here's the deal. I don't know what big B is. I don't know what little c is. I don't know what little a is. But I can figure out big B just subtracting the other two angles from 180. So I'm doing 180 minus the 23 minus the 131. That gives me 26. And because I have that 26 and I have little b also, I can do sine 26 over little b equals sine 23 over little c. And don't forget, the way we punch that in, we're going to cross multiply that way. 10 times sine 23 divided by sine 26. And I got 8.9 for little c. I'm going to use the same fraction again, the sine 26 over 10. Except this time I need to find little a. So I'm going to put big A on the top. Now, by the way, little a is going to be bigger than little c because the angle A is so much bigger. So I'm going to cross multiply again. 10 times sine 131. Divide that by sine 26. Getting 17.2, which is twice as big, which is pretty big. So there you go. Hope it makes some sense to you. That was fun. Make a good grade tomorrow. See you then. Bye.